Welcome to qiphyedu. Today we're going to look at Computer Science Paper 11, May-June 2021. This is my first video on A-levels and also on computer science. The reason why I'm making this series of videos is because I realize that on YouTube or other video sharing platforms, there is very limited content related to A-level computer science, and students like me would want to have content related to computer science to help make our studies easier, especially for past year papers, so that there'll be like explanations and all these things. So I'm making this series of videos to address that issue, and I'm also going to be doing videos related to other subjects as well besides A levels. The most notably will be SPM. I'll be making videos on past year papers for SPM subjects as well. So stay tuned if you're an SPM student. And for today, we're going to look at A levels computer science, right? So I'm going to move on to the first question for this paper. So let's take a look at the first question. Here it says, Anya scans an image into a computer for a school project. The scanned image is a bitmap image. Okay, so here's the point. Main point here is bitmap image. So as you know, bitmap images are represented with pixels. So what are pixels? So that's where we need to write in the definition right here. So pixel is basically a single square of one color. A single square of one color. So if you look at our computer monitors, although it's not very obvious, but if you use your camera and you zoom in all the way to the maximum, you see that there's actually very small squares. These squares are known as pixels. Now this is basically how resolution is built up, how our images are, how the image resolution is made up of, is all based on pixels. So besides saying that it's a single square of one color, you can also say it's basic unit of an image. So each monitor is basically represented by pixels. So that's why we have terminologies like resolution, for example, let's say 1080p HD. This basically means that the vertical resolution of either the vertical resolution or the horizontal resolution of the screen itself is 1080 pixels. All right, so it's made of pixels. So every time, if let's say you were to enlarge a bitmap image, because of the way the image itself is constructed, which is the pixels, if you enlarge the picture, the squares will become larger. That's why the pictures itself will become pixelated. That's for bitmap images. And then whereas vector images, they are made up of instructions to draw the shapes. So when you increase the size, it will only change the instruction to make the shape larger. So it won't make the picture pixelated. It will just make the picture larger by changing the instruction of the shape to make it larger. Yeah. So that's the difference between bitmap and vector. Okay, moving on to file header. So file header is basically where all the data about the bitmap image is stored. So data about the bitmap image. So what kind of data will be stored in a bitmap image? Data, let's say for example, okay, there'll be one example that you can use, which is a date taken. So date taken would be an example of the data that will be stored in the file header. Okay, so this is basically where all the data related to the picture will be stored. Okay, so now we move on to the second question, which is the image is scanned with an image resolution of 1024 by 512 pixels and a color depth of 8 bits per pixel. So how to calculate this in megabytes? Now many people will be confused between megabytes and megabytes, but actually there's a very distinct difference. Now megabytes is calculated with base 2. Megabytes is calculated with base 10. So every time you see like megabytes or megabytes, the easiest way to differentiate it is actually this BI thingy in the middle of the word. BI means binary, right? You can use it as a short form of binary. That's how you can determine whether or not the format should be base 2 or base 10. So megabytes itself is basically 1024 kilobytes, right? So all you need to do for megabytes is you need to divide it by 1024 instead of 1000. For megabytes, it will be 1000. So here, we need to calculate first the resolution, which is 1024 times 512, and then color depth of 8 bits per pixel will be times 8. But then, if you want to do a shortcut, like you don't want to finish like calculating every single thing, you can actually omit the 8 bits, because we're going to be converting it to bytes later on. So first from bits to bytes to kilobytes, and then finally megabytes, step by step. So here, I'm going to calculate 1024 times 512. Now, that would be okay. So that will give us okay, so this will give us 524,288 times 8 bits. Now, I'm going to do the shortcut way, but if you don't want to do the shortcut way, you need to multiply by 8. But here, I'm going to assume that I have already divided by 8, because 1 byte equals to 8 bits. So later on, you still need to divide it by 8, because in order to get bytes, the equivalent number of bytes, you need to divide it by 8. So I'm going to assume that I have already divided by 8. So I'm going to get the answer. Well, I'm going to get the answer, which is 524,288 bytes. And then here, we're going to convert it to kilobytes and megabytes. So all you need to do is to divide it by 1024, and then by another 1024. So here, when you divide, that would be, because you're not allowed to bring a calculator into the exam hall for computer science A levels, so we need to do it manually. Okay, so here, so 5 will be 5120, and then 14. This will be 1228. This one is 1024. 2048, so this is 2, and then here we'll get 512 kilobytes divided by 1024, and then this is basically 1/2, because 512 divided by 1024 is, if you actually just simplify it, it'll be 1/2, so you get 0.5 megabytes. So the final answer for this one is 0.5 megabytes. Okay, so here, for B, the image is compressed using lossless compression. Identify one method of lossless compression that can be used to compress the image. So here the main point would be lossless compression, and one method of lossless compression, and describe how it will reduce the file size. So for common lossless compression methods would be Huffman encoding or run length encoding. So for this one, for compressing image, mostly we'll be using run length encoding, also known as RLE. And then the description would be where we explain how this run length encoding works. So here, for run length encoding, it replaces sequences of the same color pixel with the code and count or number of similar pixels, or you can say identical pixels. But don't put a slash during the exam. Don't do that. Just put one answer. That'll be better. Just put like one term, this or this, right? So, for example, I'll actually just explain briefly about how run length encoding works. So maybe we'll have like lines of characters, let's say like C, 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 and then we have like D, E, E, F, something like this. So these will be replaced into something like this: 3C, 1D, and 2E, 1F. So this is how it's compressed. This is a example of how it's compressed. If you compress it by replace the sequence and then you change it to like for example C there'll be only be one C, but then you state that there are how many C's for that particular sequence. So instead of CCC, instead of CCC, it will be 3C, and then for example instead of saying D, there's one D, and instead of saying that EE, there'll be two E's. Yeah, that's how how it saves space. This is actually much better if you have like a long list of a sequence that has the same similar characters. So that's how it saves space, because you just have to represent the number of characters that are within that sequence. Okay, and then for C, it's basically just binary conversion or hexadecimal conversion and all those number conversions. So here it says FC is the amount of red, 23 is the amount of green, and 8A is the amount of blue in the color. Convert the hexadecimal code FC into denary. FC in binary, that would be let's say, okay, so for hexadecimal, there will only be numbers from 0 to 9. Starting from 10, it will be in alphabets. So A will be 10, B would be 11, C would be 12, D would be 13, E would be 14, and F would be 15. That will be the last one. And then for F, that would be 15, also known as 1111. And C would be 12, which is I have to calculate this one, so that would be 1100, if that's correct. Yeah, 13, 14, 15, yes. So this is how you get your binary. Your binary will be 1111, 1100. So then you convert it into denary. This is how I do it. So 2 power of 0 here, 2 power of 0, 1, 2 power of 1, 0, 2 power of 2, 2 power of 3, 2 power of 4 until 7. So then you add up all the numbers together. So here 2 power of 7, we know that it's 128. So 128 plus 64 plus 32 plus 16 plus 8 plus 4, and then you'll get the answer, which is 252. Yeah, so you get the answer, which is 252. That's for hexadecimal. The amount of green in binary is 001000011. This has the denary number 15 added to it to create a second color. Add the denary number 15 to the binary number 00100011, give your answer in binary. So now we need to convert the denary number to binary number. It's much better to do it that way because you don't have to convert it back to binary again. Might as well just convert the denary number beforehand and then add it up with the binary number later, and then you get your answer in binary. So converting the denary number to 15, all you need to do is to take 15, divide by 2. So that's why you get the remainder of 1. And then here we divide by 3. Divide by 2 again, we'll get 3, and then we get remainder of 1. And then same goes for every single division. So here we get 1, 1, 1, 1. So if you convert that to binary, that'll be 0, 0, 0, 0, 1, 1, 1, 1. Yeah, if you're not confident with your answer, you can just start from the right hand side. Start from the right hand side, which means that this will be 1, this one will be 2, this one will be 4, this one will be 8. 2 power 0, 2 power 1, 2 power 2, 2 power 3, basically. So you add up together, you see if you get 15 or not. If you get 15, then it's accurate. And then now we're going to add 0010, 0011. So 0000, 1111 plus 0010, 0011. So when you add this together, 1 plus 1 would be 0, and then you move the 1 to the other side. And 1 plus 1 would be 10, and then 10 plus 1, 11. So you move the 1 to the other side, 1 plus 1, 0. And you move over, there'll be another 1 here. So same goes for the others. So 1 plus 1 is 10, but here is 0, so we move it to the next to the next number on the left. Next number on the left. So 1 plus 0 is still 1. This one 0 plus 1 1, and then 0 0. So answer we have 0 0 1 1 and 0 0 1 0. This is the answer for adding the denary number 15 to binary number 0010 0011. Okay, so hexadecimal 23 in 2's complement representation is 00100011. Denary number 10 needs to be subtracted from this value. Subtract the denary number 10 from the 2's complement representation of 00100011. So we need to subtract the number. So first of all, we need to convert the denary number into 2's complement representation, or binary, but it has to be in 2's complement. So same thing, we just have to convert this one to binary. So this would be, like such, and then you'll get 00001010, and then there's actually two ways to do this. You can directly so this would be 00100011 minus 00001010. So this one you'll get 0 0 0, and then there'll be 10. When 10 minus nothing, so you still get 10, but because we need to move it to the other side, so we need to we'll leave a 1, and then the 10 move over to the next one. Minus 1, you get 1, and then 0, and then 0, and then 1. Okay, so when you minus the answer, minus the denary number 10, you get this answer. So this is the correct answer, which is 00011001. If you want to like use plus instead of minus, you need to change the 10 to 2's complement value of -10. You need to convert it to -10, which means everything on top you need to change to like this. So always remember, for 2's complement, if you have a negative number, you first have a positive number, then you change to negative by changing all the zeros to 1, but your rightmost 1 must be remained as 1, and then 0. The far right. So you need to count from the right hand side. So if let's say your right hand side is 0, just leave it as 0. And if there's a 1, then you leave it as 1. Then the numbers on the left side of that rightmost 1 must all be changed to either 1 or 0, depending on what was it before, right? So here, if it's in negative, if it's from 10 to -10, that would be something like this. Yeah, that would be 1 1 1 1 0 1 1 0, right? Okay, so now Anya made sure that the image was not subject to any copyright. So what is copyright? So copyright is basically legal rights to ownership. Of own work. This is mostly used for digital items like your pictures, your videos, your software are all subjected to copyright if you created yourself. It belongs to you. So that's what copyright means. And then since this is a 2-mark question, you need to put another point. So this one, we'll put like this: protects against unauthorized reproduction of books. Which means that if anyone wants to use your digital media, your pictures or whatnot, they need to get permission from you first. Otherwise, you have the rights to actually to sue them for using your image or your digital products or whatnot. You can actually appeal, file an appeal, not appeal. You can actually you can actually uh, it's actually under the DM it's actually under the MCA. So whatever digital items that you digital products that you made yourself, you have the rights to it. So no one else is allowed to use it, basically. Right. So move on to the second question. Bingwen's computer comes with an operating system and utility software. Okay. So this one is our chapter 5. So here are the 4 utility software. So there will only be one-to-one uh, matching for each utility software in this description. So this formatter, it actually yes, it formats the disk, but before you format the disk, you need to initialize the disk as well. So main job of a disk formatter is also to set up a disk so that it can be used for whatever you wanted to use it for, like copy and paste files and all those. So this formatter would go to number 4, which is sets up a disk so it is ready to store files. Right? Defragmentation. So if you study chapter 5, you know that for this defragmentation, because for files, they are stored on different sectors of the disk, and files that are actually related to each other, they are stored in different areas, causing the hard disk performance to slow down. Like say for example, you have like a folder with different types of files, but then these files are scattered across the hard disk, which actually slows down the speed of the hard disk. So in order to make it faster, these files are grouped together so that they are contiguous. So here for defragmentation, that will be most part of files so that they are contiguous in memory, right? So backup is where you create another copy of your own personal data so that in the event where the disk itself has issues, at least you still have a backup so that you won't lose everything in that disk, right? So yeah, so or for example, let's say you delete your original copy and then you're like, oh my god, where did I uh where did I where did I save my files, or where did I put them? So at least you still have a copy in case you lost them. So this one would be for the last one here. And then this repair will fix the disk, so that will definitely be this one, which is scans for errors and corrects them. Identify 4 key management tasks the operating system will perform. So the keyword here would be management. So this is it's not scattered around textbook, it's easy to find. So the 4 key management tasks would be memory management. This is one. This manages the memory. Hardware management, which manages the hard drive. Security management, which manages the security on your computer. And then the last one would be file management. There's actually another one, process management. So this also depends on how much you have memorized. If you, like for these types of questions, you only need to put 4. So yeah, you can put in either one. There are actually 5 in the textbook. They are actually more. They are the more common ones you'll see are these 5. So yeah, so you can technically just memorize those, and then normally there'll be questions on this for passing papers. All right. So now we look at question 3. So this one is about the processor. So something holds the address of the next instruction to be loaded. The address is sent to the what, and then the something holds the data fetched from this address. Data is sent to something, and the control unit decodes the instructions opcode. The something is incremented. Okay, for this specific function, which is holding the address of the next instruction to be loaded, this will be your program counter. And then the address is sent to the thing that holds the memory address, which is the memory address register. And then holding the data fetch would be the memory data register. The data is sent to the what, which is for the instruction to be to be in operation. So that would be your current instruction register. And then afterwards, the program counter will be incremented. All right. So now we move on to B. So here we have 2 pages. First page is the instructions and the explanations, and then second one here would be your contents and your ASCII code. So here you need to draw a trace table. So here they already give you 1, 3, 6, 5, 6, 6, and 0. And then first we need to move on to the main instruction, which is 200. The first instruction here is 200, so we need to write it down at the second row. Second column. So that'll be 200. And then the accumulator has LDD 65, right? So what is LDD? LDD is basically direct addressing. Load the content of the allocation at the given address to ACC. So now it asks us to load directly the content of address 365. So here, memory address 365, the content that's in there is 1. So just have to put 1 in the ACC, and then we can move on to the next instruction address, which is 201. Now 201 wants us to compare 366. So compare 366 with your accumulator. So 366 is 3 and 365 is 1. So when you compare, you don't have to write anything here because you're just comparing. So we can just move on directly to the next instruction address. The next instruction address 202 says jump to 209 if the comparison was true, right? So if you look here at JPE, following a compare instruction, jump to address if the compare was true, right? So if you compare 3 and 1, that will be false because they are not the same number. So all we need to do is to just move on to the next instruction. So 203, increment accumulator, so accumulator becomes 2, and then we move on to the next instruction, 204. 204 wants us to store the data of 365, store the data into 365, store the data of the accumulator into 365. So here accumulator is 2, so we need to store the content of the accumulator into memory address 365, so that'll be 2. All right, then move on to the next one, which is address 205. 205 here wants us to move the data into the IX, which is our index register. So here, normally that would be move the contents of the accumulator to the given register. So we need to move the content of the accumulator, which is this one, into the IX, which is here, right? We move on to 206. 206 would be LDX 365. This is index addressing of your 365. So in 365 that would be 365, and then you need to add the IX, which is 367. So 365 plus 2 is 367, so 367 is 65. So here in the accumulator that would be 65. And then 207, next instruction. 207 wants us to output the code. So here it says it is 365, so not 365, it's 65. So we look at the ASCII table, 65 is A, so it's going to output A, right? It's going to output A. And then we move on to 208. 208 is jump 200. So JMP 200, that would be jump to the given address. So now we are going to jump to 200. And then address 200, same thing again, LDD 365. Our 365 is now 2, so we add 2 into the ACC. And then 201. 201 is to compare with 366, but 366 is 3, so it's still false, so we can just jump directly to 203. 203 is increment accumulator, so increment it by 1, so we get 3. Now we move on to 204, same process again, which is to store the data of the accumulator into memory address 365, so we get 3. And then 205 would be move the data of the accumulator to the index register. So that would be here, right? And then 206. 206 is index addressing of 365. So 365 plus the index register, which we will get 3. So 365 plus 3 will be 368. 368 content is 66. And then 207 is output. So if you look at the ASCII code, 66 would be B, right? So it's going to output B. Okay, now 208. 208 is asking us to jump to 200. So okay, we jump to 200. So 200, and then now we need to load again 365. 365 is 3, so here's 3. And then 201. 201 is compare 366. Now 366 is 3 and the accumulator is 3, so it's true. So 202 is jump to 209 if it's true, so we're going to jump directly to 209. And 209 itself is N, so that means that we have stopped. The trace table will be like this. Alright, so hope you get an idea of how to do trace table. Right, so now we move on to C1. The accumulator currently contains the binary number 00110101. Write the contents of the accumulator after the processor has executed the following instruction. LSL2. Now basically, LSL is you move the content two times to the left, like move 2 units to the left. So yeah, if you look at LSL, it's bits in ACC, bits in the accumulator are shifted logically n places to the left. Zeros are introduced on the right hand end. So here we need to move 2 places to the left. So when we move 2 places to the left, that means that these 2 values will be gone, and then will be our first value on the left. So that'll be 1, and then along with all the numbers on the right, so that'll be 1 1 0 1 0 1, and then zeros are introduced on the right hand side, so here will be 0 0. This is the answer for LSL2. And then the accumulator currently contains the binary integer 00110101. Identify the mathematical operation that the following instruction will perform on the contents of the accumulator. So LSR3 means that your binary number will shift logically 3 places to the right, which means that these 3 numbers will be omitted, and then there will be zeros on the left, like such. And there's one mathematical operation to it. So now, okay, imagine that you are doing division. So when you do a division, like dividing by 1, you'll still get the same answer. But if you divide it by 2, then that means that you're shifting 1 place to the right. Okay, why is that so? So now I'm going to convert this number into denarii. So when I convert it to denarii, that would be 1 plus 4 plus 16 plus 32. I'll get 53, right? So now, assuming, now let's try and divide it by 2. When you divide 53 with 2, you'll get 26 with a remainder of 1. So now ignore the remainder, and then we're going to convert 26 to binary. Okay, when we convert it to binary, well, that would be 26 divided by 2. So that would be something like this. So now when we arrange it, well, we'll get 0 0 0 1 1 0 1 0. Now see what happens. So here, when we compare this value with the one on top, you realize that 1 0 is introduced on the left, and then the sequence is the arrangement of the numbers is still the same, 1 1 0 1 0, but this 1 on the right hand side, farmost side, is now omitted, and everything starts from this side, and then there's 1 0 introduced on the left. Yeah, so that's why it's division, because when you divide, you actually get a value that is the same with doing the LSR operation. So when you move 3 places to the right, you're essentially dividing. Okay, so you have to look at it this way. So this position is basically when you're doing 2 power 1, right? So when you move it to the right, that means that it starts from 2 power 1. That's why you need to divide it by 2. Now this one is 2 power of 2, which is 4. This one is 2 power of 4, 2 power of 3, which is 8. So when you move 3 places to the right, that means that these 3 numbers will be gone, and then you'll start from the number which is placed in this position where it's 2 power of 3, which is 8. So that's why it's division of number by 8. If you want to add more, you can just say only whole number retained, which means that there is no remainder. All right. I'll move on to question number 4, which is Melinda and her friends set up a peer-to-peer network between their computers to share data. Describe the key features of a peer-to-peer network. So in a peer-to-peer network, you essentially connect one computer to another. So let's say I have this computer, I connect it to another computer, one cable, and then I connect to another computer with another cable, and then this computer here will also connect to another cable, and then this goes on and on with all different computers, right? So describe the key features of a peer-to-peer network. So because now you do not have a server, that means your computer itself is either a client or also as a server, which means that all the computers are of equal status. So that means that their status is the same because both of them can act as a client or as a server. So here we will just say all computers are of equal status. And computers can communicate and share resources. Because now, instead of actually getting the resources from the server, you're getting the resources from another computer. So each computer can communicate and share resources instead of communicating with the server in order to get the resources from there. But then in a peer-to-peer network, there will be drawbacks as well compared to using a client-server model. So two drawbacks would be because there's no server handling all these computers, that means that you are responsible for your computer's personal security. So when you only use a peer-to-peer network, if you use a peer-to-peer network, that means your security will be reduced. So there'll be reduced security because not all computers are protected. Like maybe some computers, they will have viruses, they will have malware that can be transferred across to another computer if the user is not careful about security measures on his or her computer, rather than actually connecting directly with a server, which is much more secure because there is a central server protecting the computer from getting these malware, because because the server doesn't transfer the malware from another computer to another. Your computer will only communicate with the server to get the data to and fro, right? So there's reduced security because each computer is at risk from viruses from other computers. And then another drawback would be if you want to share files, you must make sure that the computer is turned on. Because if not, if your computer is turned off, the computer cannot communicate with the computer because the CPUs is not turned on, the hard drive is not spin up, so it's impossible to get the data from the hard disk if it's not powered on. So all computers need to be switched on. It should switch on to share files. If not, the files may not always be available. Because we all may not always be available. Like we know that for servers, most servers are turned on 24/7. Rarely we'll see servers shutting down unless there is really an issue with the server. And then we have a lot of backup servers as well. So the computer can either connect to this server, or if it's powered off, you'll go and connect to a backup server. But there is only another computer with, let's say, unique data. Let's say you want to get file A from this computer, but this computer is turned on, then you turn off, so you cannot get file A. So in that case, the computer has to be turned on in order to get the data. So if let's say the computer is not turned on, you cannot get the data, which is troublesome, right? So this is the two drawbacks I think will be that suits peer-to-peer network. And then now we're going to move on to C. So here, Melinda connects her laptop to the internet through her router. So what does a router do? A router receives packets from devices, right? It receives packets from devices. And then number two, finds the IP address of a URL. The 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 item that finds the IP address of a URL is not a router, it's a DNS. So this is not right. Directs each packets to all devices attached to it. This is the role of a hub, not a router, so this is not right. And stores the IP address of all devices attached to it. Yes, this is performed by the router, right? So this would be the answer for this 4. Melinda mainly uses the internet to watch films and play computer games. So most gamers out there will know that a wired internet is very important because this can reduce the latency, or people will say ping, right? So let's say you want to get the lowest milliseconds. So most people who are playing games or watching films, binge watching films, they will prefer to use a wired network, right? If you are using a PC, most people who play games will normally use PCs. So so you have two choices. One is you can use wired or you can use wireless. But for me personally, or based on the answer scheme, uh, you can technically, it's much better off when you said wired, because there's more reasons for it. So why you would prefer to use a wired network is because there will be lower latency, as it's more reliable. As it is more reliable. And there's a problem with wireless connections, which is because it's transmitted through signals, there'll be interference through walls. So we can write that as well. It's less susceptible to interference. And it has a faster connection. So yep, that's how you get your 3 marks. Actually, this is already more than 3 marks, but it's much better if you have more reasons, you put it in, you get a much better guarantee of getting marks, right? So Melinda sends emails from her webmail account. Explain whether Melinda is using the internet or the World Wide Web. So if you want to access websites, you need to use the World Wide Web. But if you want to send data across, you need to use the internet in order to access the World Wide Web. Basically, you need to have these two things in order to you need both of them to access your email, right? So basically you're using both. Okay. And then you need to say that she is using internet to send data on the infrastructure. Infrastructure here could be server, basically. That's where the data is stored. And using www to access a website. That is stored on a web server that is part of the World Wide Web. Right. So websites have to be accessed, which is part of the www, and then you need to use the internet to transmit the data to the server. So you need to have the internet in order to do that, because the server is from like a very far away location. It's not a local area network. It's from a server from a different location. You need to use the internet to do that. And then if you want to access the website, it's part of the World Wide Web, so you need to access the World Wide Web as well, right? So move on to question number 5. Kara has a washing machine and a refrigerator. Describe what is meant by embedded system. So embedded system is basically a computer, or it's basically a device that only performs one specific task, right? So here we can write microprocessor that performs one specific task. for example, the embedded system, in the washing machine, only controls the programs for the washing cycle, like how you want your clothes to be washed. Right? So the washing cycle. Yeah, so this is how I get 2 marks. And then the washing machine embedded system makes use of both RAM and ROM. RAM is volatile memory, whereas read-only memory is random access memory is volatile memory, whereas ROM is non-volatile, which means that for random access memory, if you turn off the computer or you turn off the device, your data will be immediately gone. But for read-only memory, the data will be stored for a very long time. So for RAM, for the washing machine itself, what does the RAM do? The RAM stores the you can put examples. Like if let's say like for example you want to wash your clothes, but you want to wash it for like how many minutes? So the RAM stores the time left in the program. So like how long you still need to wash your clothes? Like how long will the washing machine still need to wash your clothes? Or you can also say store choice that the user has selected. Like let's say for example the user only wants to spin their clothes so that it's dry instead of just washing, or the user wants to wash their clothes and have it go through an entire washing cycle. So that could be a choice as well. And then ROM stores the startup instruction. So when you turn on the washing machine, there will be a list of choices that you can make for your washing for the washing cycle. But you need to load it up first so that it can be identified when you press the controls on the washing machine. So this stores the startup instructions. Right? Temperature in a refrigerator must be kept between 4 and 6 degrees Celsius. The microprocessor in the refrigerator turns on the cooling if the temperature is too high and turns off if it's too low. Now, I'll explain why it's a control but not a monitoring system. Okay, so because as you can see, the cooling is turned on when the temperature is too high, and the cooling is turned off when the temperature is too low, which means that it's not maintained. Like for example, the temperature must be kept between 4 and 6 degrees Celsius. That means that it can fluctuate. Let's say for example, maybe it's 4 degrees, then suddenly it becomes 5, then 6 degrees. It's not stable. It will only go down to that particular point where you turn on the cooling. So instead of maintaining it at let's say 5 degrees Celsius, it fluctuates between 4 and 6 degrees Celsius. So it's not monitored at that actual level. It's only controlling the temperature to be between 4 and 6 degrees Celsius. So, so you can see that it turns on the cooling if the temperature is too high and turns off the cooling if the temperature is too low. So it will only activate under certain circumstances, right? So that means that the system uses feedback. And system, and it causes the temperature to change. So it's a control system rather than a monitoring system, right? That's for this question. Each of the following algorithms performs data validation. State the type of validation check that each of the algorithm performs. Okay, so now you input a value, let's say x for example. If x is less than 0 or x is more than 10, then output invalid. So that means that the length of this value must be between 0 to 10. So that means that it must be between 0 and 10. The length itself, the range itself must be from 0 to 10. So basically this one will be range check. Mostly like if you let's say you type in a value and then the value itself is over 10, like let's say for example your let's say you type in like your age, for example. If your age is like 11, then that means that it is not within the range. Some students may be confused with length check and range check. Length check would be the length of the length of the character. Length that'll be like the number of characters. Like let's say you have 5 characters, so you must be between 3 to 5 characters, something like that. That would be part of length check. Range check is like the value itself must not be over a particular amount of that particular set of instructions that they have given. So it cannot be over 10, for example, like for this question. Okay, input x. If x equals nothing, then output invalid. So this is your presence check. You need to check to see if there's any number or any value inputted into the system. So this is presence check. The third one, if not x equals red or x equals yellow or x equals blue, then output invalid. Which means that if let's say the value itself doesn't include red or doesn't include the yellow or is not blue, then it's invalid. So that means that you must check to see if these words exist or not. So this is an existence check. Alright. Okay. Question number 7. Bobby and Kim are discussing databases. Bobby tells Kim that a file-based approach is usually better than a relational database. Now, of course, if we learn chapter 8, we know that this is false, and we need to tell Bobby why this is incorrect. So we need to remember these 3 things for DBMS. That would be for relational database in particular, that would be data dependency, data redundancy, and data consistency. So if you use a file-based approach, that means that there will be that the data dependency itself is very low, right? And then data redundancy, there will be higher data redundancy because if you store in files, if you store in using a file-based approach, that means that there'll be probably 2 or 3 files with the same copy of the data, which uses up more space. And consistency because when you update your particular data in one area, it's not updated everywhere. So you need to update it like for every single file, which is very troublesome. So that's why it's inconsistent and increases data redundancy. And the dependence of the data, instead of data dependency, instead of just depending on the primary keys and so on, it's actually program data dependence with flat files, right? So the dependency is basically very weak. You need to rewrite every single thing, right? So I'm going to use these 2 as an example as the main reasons why Bobby is incorrect. So I'll say there is more data redundancy with flat files because the same data is stored many times. Okay, second one, data consistency. Not only that, flat file has more data inconsistency. Because when data is updated in one area, it is not updated everywhere. Right? B, Bobby has a shop that sells products to customers. His database will store data about his customers, their payment details, orders, and the products he sells. Customers will have to log in. Alright, so the main point here would be the customers, the payment detail, order, and product he sells. Okay. So here, give one example of each of the following relationship from Bobby's database. Now, one customer will only have one payment detail, or one customer will only have one login details. Oh yeah, and also this one, login details. So customers will only have one login detail, one account. So one-to-one, it could be either customer to payment details or customer to login details. You can choose either one, and it will be accepted. One-to-many, one customer can have many orders. Orders for a particular product can be many products. So customer to orders. Many-to-many would be you have the order, there's many orders, and then it will relate to many products, right? So that will be order to product, or customer to product, because many customers would probably choose many products, right? So customers to products, right? And tick one box to identify the relationship that cannot be directly implemented. This will be many-to-many, right? The others can be implemented in a normalized relational database, but not many-to-many, right? So remember that. And then 7C, 7B3. Bobby wants to name his database shop orders. Write a DDL statement to define a new database with the name shop orders. All right. So if you want to create a new database, you need to create a new database. So basically just write create database and then the title, and then that's it, right? So this one will be create database shop orders, right? And then you put semicolon. Yep, that's it. A database has a data dictionary, right? There's a data dictionary. So give 3 items that are stored. That would be your product key, your primary key, sorry, your foreign key, your table name. It could also be something else, like for example, your field name or your data type. This depends on what you memorize. You can choose to put which one you like. You can put these as well, right? Tick one box in each row to identify the logic gate that each statement describes. The output is 1 only when both inputs are 1. So okay, let's look at each one. So for n, if let's say it's 0 and 0, 0 and 0, you get 0. 0 and 1, you get 0. 1 and 0, you get 0. But 1 and 1, you get 1. NAND will be the other way around. So 0 and 0, you get 1, and then this one you get 1, this one you get 1, this one you get 0, right? So the output is 1 only when both inputs are 1. NAND is out of the question already. And then NOR. So for NOR, 0 nor 0, you'll get 1. Because 0 or 0, you get 0. So this one, 0 nor 0, you get 1. 1 nor 0, you get 0, because if it's 1 or 0, you get 1. Same goes for the other one. So this one will also be 0. And then 1 nor 1, you get 0, right? And then all will be the other way around. So 0 or 0, you get 0. 1 or 0, you get 1. 0 or 1, you get 1. 1 or 1, you get 1, right? And then for XOR, the only difference with OR is that if it's 1 or 1, you get 0. So this one would be 0, 1, 1, 0. Alright, so now we have a clear idea of what we want here. So for output is 1 only when both inputs are 1. So here we see that would be N, because all the others are 0. The reason why all cannot be accepted is because there are other statements that will give you a result of 1, so all cannot be accepted. Only accepted answer here is N. And then the output is 1 only when both inputs are different. Alright, so this one would be output is 1 only when both inputs are different. Only when both inputs are different. So 0 XOR 0, you get 0. 0 XOR 1, you get 1. 1 XOR 0, you get 1. And then 1 XOR 1, you get 0. So this fulfills the requirements for this statement here. And then you look at the others, you see at some, for example, like 1 nor 1, you get 0. And then, sorry, 0 nor 0, you get 1. And then here, like 1 or 1, you get 0. So this cannot be accepted. Same goes for NAND and AND. So this one is your XOR. The output is 1 only when both inputs are 0, right? Only when both inputs are 0. So this will be NOR, because if you look at all the others, right, it's all either they have 1, either they have 0, or the other answers have 1 as well. So only NOR doesn't have that. So 0 nor 0, you get 1, right? So this is the answer for this one, right? So that's the end of this paper. Thank you for watching. Stay tuned for other past year paper discussions like this, and don't forget to subscribe, and I'll see you then.